Hey, and welcome back. You're obviously enjoying this if you're still putting up with this. Trying to get the boring bits out. 757 update. So, part 2 of this. I left you before when I said I've got no TX 13.8 volts. No switching happening on that at all. Did some more digging, looking at all the schematics. On page 34, there's a really good block diagram of the interconnection between all the boards, which makes it a lot easier to work out where it's all going. A bit more digging, following it through to the RF board and to the logic board, shows to me that it doesn't originate anywhere there. It actually does originate on the PA board, and it's based on some buffering and delay of the PTT signal and the battery input voltage. And effectively, a NPN transistor pulls the base of a PNP power transistor to ground, saturating it, creating a 13.5 volt plus supply signal on the collector of that transistor. That transistor is in a TO220 case and it's cooked. It's not switching. Following that a little bit further and actually shorting that one out to see if we can control that, turns out that that then feeds the pre-drive and the bias to the drivers and a voltage regulator, which then does the high level bias to the main power transistors. That voltage regulator is cooked. It's a 7808, so it's an 8 volt voltage regulator. I'm not sure exactly the mechanism there. But the thing is, the output from the TX 13.8 volt switch, the TO220 PNP transistor, goes through those 2 pins on the power connector. So firstly, I don't know why you would do that. Admittedly, I haven't read the manual completely, but I didn't see anything on my superficial look. It could only mean that if you don't have those wires jumpered, that the PA doesn't transmit. The problem is, if you don't know, like me, that the drawing is wrong or somebody's twisted the connector around or something, you can put reverse voltage on the TX supply line unprotected into the thing. So I'm not sure why it got cooked, but that transistor, that PNP transistor, is cooked and the 7808 is cooked. If I bypass all of those, turn the volts down on the input to 8 volts and keep it latched, it won't power up at 8 volts, but if you power it up at 12 volts and then turn it down to 8 volts, you can jumper the 8 volt regulator and check the bias circuit as well. That seems to be working, but I'm not sure if the RF power transistors are toast or not. Normally they cook short circuit. I haven't seen any cook open circuit, so fingers crossed that they're okay. Still not sure why the TX 13.8 volts is fried though. I'm still thinking it has something to do with those output pins because there are signs of arcing on those connectors, so somebody's faffed around a bit there. So I took that a bit further and I still don't have 13.8 volts on the TX line of that connector that goes to the other boards, because I was trying to see if I could get RF drive out of the RF board, and on closer inspection that pin is directly connected to the pin on the back. It should go high when we PTT or when we force PTT. It's not. And if I really look closely, and I'm not sure if I can show you, we'll try. They've actually fried a track in here. Let me see if I can zoom in and get it to focus. I don't know how to focus. Here we go. Will it stay focused? Right there in the middle of the screen, next to that green capacitor, I think you should see that there's a fried track, and that track is the 13.8 TX to that connector, and it drives the, sorry about that, it drives the logic on the other boards, and it also drives to the low pass filter board on the output. So potentially something around there has cooked. Usually though, the fuse doesn't protect the track acting as a fuse doesn't protect the PNP transistor. The fact that PNP transistor is cooked makes me think that it's come from the other side, and that overvolting, I'm going to have to look. It may have actually cooked something on the other end as well, if we've gone reverse volts or something. I really have a sneaky suspicion that they put reverse 12 volts between ground and that TX 13.8. Good chance that then would have cooked the 7808 regulator. I can't see how that would have fried the PNP transistor. Yeah, I'm not sure about that. And then cooked something else down the path to fry that track, to fuse out that track. Yeah, look, it's a bit of detective work. If anybody has any ideas, if you're familiar with this, or if you want to download the schematic and have a look, see what you can think of. What would have cooked that transistor Q8, the voltage regulator, which is what is it, Q6, and the track going to connector number 3, I think. Anyway, it's the 5-way header that takes the 13.8 volts, the PTT, the ground, and the TX 13.8 volts to the other boards. So between those two, that track is cooked. So I'm now going to have to pull this board off. I was hoping I wouldn't have to, but I don't have access to the screws for that transistor. And I could bodgy something up and solder it on top, but I want to do this properly. So I'll be pulling this board out and making those repairs. And then we will see from there what's next. What is next indeed. I'm going to have to work out why we're not getting LO drive, because even when I bypass all of that stuff and put the TX 13.8 volts in, I'm still not getting RF drive out from that board, even in FM mode. So I should have been getting something. So that's the update. I think it's going to be a couple of days before I get around to pulling this off, because that's a big job, pulling that PA board off. There's a ton of screws and heatsink compound and stuff I've got to be careful with. And then we'll have a look at what is cooked on the other side of this board. So anyway, I'll keep you updated. If you want to hear more of this radio and any of the other projects, please hit that like and subscribe button. I really appreciate everybody who's watching this, and if you've got any comments, feel free. I will try to answer everybody. Please put comments, and I'll keep you updated. Hey everybody, thanks for watching.